Because alcohols are commonly made in organic synthesis, either as end targets themselves or as intermediates as we proceed with the synthesis of a different target, it would be useful to take a look at the methods we know for making them now that we know several different methods. Take a look. We can make these guys from alkenes. And we know 2 or 3 or 4 ways. I'm going to put the R there to make sure we realize that this carbon is more highly substituted than the other one. And remember that if we use sulfuric acid, with water, or treatment of the alkene with mercuric acetate, and water. The second step is reduction. We add water to the double bond, and the hydroxyl group ends up on the carbon that is more highly substituted. That's the Markovnikov addition thing. Alternatively, if we treat that alkene with borane, in an initial step, and then 2, followed by reduction using hydrogen peroxide under basic conditions. We also add water to that double bond, but the regiochemistry is the other way around, so the OH group ends up on the less substituted carbon. Remember that? There are 2 reactions sort of specialized. They put hydroxyl groups on adjacent carbons that are worth knowing about because diols pop up from time to time. And these reactions offer opposite stereochemical outcomes. If you treat with peracid, and after that aqueous acid, you make diols with stereochemistry that I'm going to write like this. So it's evident that the diols are added to ultimately opposite faces of the double bond. But if you treat the same alkene with osmium tetroxide, and some oxidizing agent, N-methyl morphine N oxide, NMO, is a really good choice. Those hydroxyls are added at the same time, so they're on the same side. So the stereochemical outcome is the opposite. So you know 4 reactions that make alcohols from alkenes. And alkenes are readily available from petroleum and from other small molecules. So those are useful reactions. We also know how to make alcohols using a substitution reaction, starting with an alkyl halide. Let's look at that. And for these, X may be chloride, bromide, or iodide as leaving groups. And for primary alkyl halides, you can do a SN2 reaction using sodium hydroxide and get reasonable yields in many cases. I'm just going to write in parentheses so you remember it. This is an SN2 reaction, and the things we learned about SN2 reactions apply. Tertiary alkyl halides can be treated with water. This is an SN1 reaction, and you can make alcohols in reasonable yields. I'm just going to put SN1 there so you remember that the things that you know about SN1 reactions apply. And notice that this is a primary alcohol. This is a tertiary alcohol. And we're not saying that this is a good way to make secondary alcohol, so put that away. This isn't something you would want to do for most secondary alcohols because elimination is a significant problem. You can also make alcohols from carbonyl compounds. Aldehydes reduce. To make primary alcohols. The reducing conditions that are preferred typically would be sodium borohydride in an alcohol solid such as methanol. But to be complete, remember that this reaction also happens with LAH in an initial step where the second step is water. Or if we use hydrogen gas with a metal catalyst such as platinum, palladium, or nickel, aldehydes can be reduced to primary alcohols. Of these three methods, the sodium borohydride reduction would normally be used. And recall that if that compound is a ketone, I'm just going to put C above. We'll make secondary alcohols. Same kinds of reagents and conditions. So this is primary. This makes secondary alcohols. And when we want to make a alcohol from a carbonyl compound and make a carbon-carbon bond at the same time, recall that formaldehyde with the Grignard reagent followed by water makes a primary alcohol. If it's an aldehyde, you make a secondary alcohol. And if it's a ketone, we make tertiary alcohol. So this Grignard synthesis of alcohols is very valuable. And finally, there's a specialized case we learned where if you start with an ester, I write the prime there, that could be something different. Same conditions. We'll end up with a tertiary alcohol. That tertiary alcohol has added an alkyl group twice, and they are the same alkyl group. So these are two ways to make tertiary alcohols. And just to be clear, we're adding this alkyl group to make the primary alcohol, the secondary alcohol, a tertiary alcohol, or a tertiary alcohol where we have the same alkyl group added twice. So there you have it. We have methods for making alcohols from alkenes, from alkyl halides, and from carbonyl compounds, either by reduction or Grignard reactions. I predict you'll find that all of these are useful